Let's talk about Leak 2435 pass in matrix whose sum is divisible by k. It gives us a n multiplied by n grid and n k. It asks how many paths, which is from 0, the upper left to the bottom right, and -1 and -1, has a path sum divisible by k. And we can move from the top right to bottom left, top left to bottom right. Just can move only to the right and to move down two directions. So we know for every cell, right? Let's look at the range and multiple by n is smaller than 5 multiplied by 10 to the fourth. And there is a key, right? There is a 50 range. So we know for every cell, and we can consider the remainder, which is divisible by k, right? So for every cell, ig, we are use another variable called v, which is for this the path from 0 to 0 to 0 to this ij. If the remainder is v, how many possible passes, right? So we need to open three-dimensional DP and multiply n and also k, right? So we know initial value is that 0, 0, grid 0 multiplied by k is 0, 0 multiplied by k is 1, right? And in the end, what we want to retain is n minus 1, n minus 1, and k, because we want to divisible, so k is 0. That means the remainder is 0, right? And for every cell, it comes to so what we need to do is that for every cell, we need to iterate those kind of way from 0 to k. And for every cell, it comes to choose coming from upper and left. So we just sum up the up pass possibility and the left pass possibility. So let's write code for this. You see that we need to mod, right? So private final static int mod equals and int m equals grid dot length and grid 0 dot length. So what we do is that we're going to have dp equals new int m and k, right? So for every value divided by k, there can be the remainder can only be 0 to k minus 1, right? So we know the initial value is dp 0, 0, grid 0, 0, mod k, right? So this one is 1. So what we do is that for int I equals 0, I is smaller than m, I plus plus, for int j equals to 0 is smaller than n, j plus plus, right? So what we do is that we enumerate those kind of remainder from 0 with smaller than k, v plus plus. So let's say if this kind of I is greater than 0, right? Then we'll have dp I j v equals dp I j v plus from the our path from the upper, right? So from the upper, that is dp I minus 1 j. So what is the v here? Because when we add grid ij and in the past add grid ij and mod k, then will be V, right? So that means that this one will be actually our V minus grid I J and mod K, right? But this one may be negative because the grid number may be big, right? Because the number can be 100. So what we do is that after we mod, right, we add K again in the mod K again, right? So also, if this channel G is greater than 0, we'll have dp I J V equals dp I J V plus dp I J minus 1. And this part is the same, right? Because for these two parts, they all add grid ij. And for this value, actually, we need to mod, right? Because it may be big. In the end, what we need is just a return dp m minus 1 n minus 1 and 0. And Python code is very similar. Let's also read the Python code for this. So we know in term we have uh, mn and the mod, right, equals length grid and length grid 0, and this one will be 1. And we need to have a dp equals this one multiplied by k for in range, and also for this one in range m. So we know dp 0, 0, and grid 0, 0, mod k equals to 1, right? And for I in range and for J in range, okay? And we just need to iterate those kind of mod reminder in range. Okay, so I say if I is greater than 0, we are going to have dp I J V equals dp I J V. So we should have plus dp I minus 1 J. And for this one, we need a K. K, we should have brackets, right? K plus V minus grid I J mod K, and have parentheses here, right? And mod K again. And for this value, we should mod because it may be big, right? So we'll say if J is greater than 0, this formula will be similar. But we need to consider those part from the left. That is I J minus 1, right? So in the end, we just need to return dp m minus 1 m minus one, and we need to make sure the remainder is zero. So the time complexity will be m multiplied by n multiplied by k. Space complexity is also m multiplied by n multiplied by k.